Hello, this is the lecture number 2 for the chapter Heron's formula for the class 9th, and we are starting with the exercise 12.2, in which in question number 1 it is given that there is a quadrilateral ABCD in which the side CD and BC are perpendicular to each other, and the side AB is given as equal to 9 meter, the side BC is given equal to 12 meter, the side CD is given as 5 meter. You have to find the side AD is given as 8 meters. You have to find the area of this quadrilateral. So it is given that CD is perpendicular to BC. This is the main thing is there. You have to find the area of this quadrilateral. You read the question from your book. Now how you have to find the area of this quadrilateral? You join the diagonal BD. Now because the triangle BCD is a right angle triangle, so you can easily find the area of triangle BCD by using the formula half base into height. The base is 5 and the height is 12. So you can easily find the area of triangle BCD is equal to half base into height. Then which is coming out to be 30 centimeter square. Now because you have to find the area of the triangle BAD and only two sides is given, and the third it is not a right angle triangle, so first of all you find a third side from the triangle BCD by using the Pythagoras theorem. Then we can easily find the area of triangle BAD by Heron's formula. So using the Pythagoras theorem in the triangle BCD, which is equal to right angle triangle, so BD is the hypotenuse, so BD square is equal to BC square plus CD square. This is the Pythagoras theorem in triangle BCD, which is CD is 5 is given, BC is 12 is given, 25 plus 144, it is equal to 169. When you remove the square root, you will get the square from the left hand side, you will get the square root in the right hand side, and the square root of BD is 169 is 13 meter. So you have obtained the value of the length BD, which is coming out to be 13 meter. Now you can easily find the area of the triangle BAD by using the Heron's formula. All the sides are given now, 8, 9 and 13. So A is 8, B is 9 and C is 13. So you find as usual the semi-perimeter, which is equal to A plus B plus C upon 2, coming out to 15. Area of triangle BAD, this is area of triangle BAD. That is under root S minus A, S minus B, S minus C, 15, 15 minus 8, 15 minus 9, 15 minus 13, that is 15 into 7 into 6 into, this is equal to 2. So you make the prime factors of this 3 into 5, 7 into 1, 2 into 3 into 2, make the pairs, solve the square root, you are getting 6 root 35. Now the value of root 35 is 5.9 approximately. So it is 6 into 5.9 is equal to 35.5 meter square approximately. The total area will be area of triangle BCD plus area of triangle DAB, which is equal to 30 plus 35.5, which is coming out to be 65.5 meter square. So this is the question number 1. We have joined this diagonal BD so that it can be divided into two triangles, because you can easily find the area of the triangle either using the Heron's formula or by half base into height. In question number 2 also, again it is given that it is a quadrilateral in which angle B is a right angle, and the side AB is given as 3 centimeter, BC is given as 4 centimeter, CD is given as 4 centimeter, and AD is given as 5. So as in question number 1, first of all you find AC is given as 5 centimeter. Now because 5 square is equal to 3 square plus 4 square, so it means the ABC is a right angle triangle. So you can find the area of triangle ABC by half base into height, that is half 3 into 4, 66 meter square, and area of ADC you can find by using the Heron's formula, where the three sides are 5, 5 and 4. This is ADC, all the three sides are given, semi-perimeter, that is A plus B plus C upon 2, then area of triangle ADC, this area of triangle ADC by using the Heron's formula, that is under root S minus A, S minus B, S minus C, 7 into 2 into 2 into 3, So 2 into 2, 2 outside, and 7 to 3, root 21, and the square root of root 21 is 4.6 approximately. You take your own time to find the square root of 21 in your rough column. It will be approximately 4.6, so it will be 9.2 centimeter square. So the area of this quadrilateral ABCD will be area of triangle ABC and area of triangle ADC. Add these two, you will get the area of the quadrilateral, which is 6.9, 6 plus 9.2, 15.2 centimeter square. Now you can find the area of the triangle ABC by the Hero's formula also, because all the three sides are given. Means you can find the area of triangle ABC by the Heron's formula, and the area of triangle ADC by also the Heron's formula, and then you can add. So this is the question number 2. Now in question number 3, it is somewhat lengthy question. In this question, a figure is given. You see the figure carefully in your book also. There's a shape containing this triangle first, triangle fourth, and triangle fifth, and there's a rectangle and there's a trapezium shape here. So we have three triangles, one rectangle, and one trapezium. Now to find the area of this figure or this to make this, you have to find the area of these three triangles, the area of the rectangle, and the area of trapezium. Now you can find the area of triangle. The dimensions of this is given. See in your books carefully. The triangle first, in triangle first, the sides are 5, 5, and 1. So you can find the area of the triangle 1 by using the Heron's formula, which is sides are 1, 5, 5, and 1. And then you can find the semi-perimeter, which is equal to A plus B plus C upon 2, which is coming out to be 5.5. Then the area of triangle by the Heron's formula, that is under root S minus A, S minus B, S minus C. Replace the value of S, A, B, and C. You are getting 5.5, 0.5, 0.5, 0.5. You know how to find the square root. 0.5 into 0.5 is outside the square root, will be 0.5. 5.5 into 4.5, like this. For 5.5 you can write 0.5 into 11. For this 4.5 you can write 0.5 into 9. Now the square root of 9 will be equal to 3, and the square root of 0.5 into 0.5 is 0.5, and the square root of 11 as it is, and the square root of 11 is 3.3 approximately. So this is the area of the triangle 2.5 centimeter square. That is the area of the triangle 1. Now you can easily find the area of the triangle rectangle second, which is equal to length into breadth. So the length is from this to this, it is given equal to 6.5, and its breadth is only equal to 1, which is 6.1. So area of the rectangle or the shape second is rectangle, which is equal to length into breadth. Now the area of the figure 4 is right angle triangle, which is half base into height. So its base is 6 and height is 1.5. You can see the figure from your book carefully. So it is half base into height, which is half 6 into 1.5, which is coming out to be 4.5, and the area of triangle 5 is also same as area of the triangle 4, half base into height, which is also equal to 4.5. Now to find the area of this trapezium 3, see it very carefully. It is a trapezium. Now you know the area of trapezium is half sum of the parallel side into height. Now the parallel sides are given 1 and 2, but its height is not given, only its non-parallel side is given, which is equal to 1. So I have drawn this figure third again here, and see it very carefully. This is 1. If you draw perpendicular from the top side to the base side, it will be the height of the trapezium. Now because this is 1, this is 1, now you can use the Pythagoras theorem to find the height of this trapezium, which is equal to under root 1 square minus half square. Now why it is equal to half? Because this side is 1 and this side is total equal to 2. Now because we have drawn perpendicular to it, so this side will be equal to 1 and remaining side will be half and half, because it is a symmetrical figure or a congruent figure. So remaining portion will be 1, then it will be half, and this is also equal to half. So by using the Pythagoras theorem, you can find the height of this trapezium, which is equal to under root hypotenuse square minus base square. See it carefully, which is coming out to be root 3 by 2. Root 3 by 2. 1 upon 4. Take the LCM, subtract it, you will get root 3 by 4. So area of this trapezium 3 will be equal to half sum of the parallel side into height. You know the area of the trapezium, which is equal to half sum of the parallel sides are 1 and 2. This from this to this base is 2 into height is root 3 by 2. So 1 plus 2 is 3. Simplify it, replace the value of root 3, which is equal to 1.732. You learn the value of root 3 and root 2. Root 3 is equal to 1.732 and root 2 is equal to 1.414 approximately. This is. So this is the area of trapezium, which is 1.3 centimeter square. Now the area of this figure is, you add all these areas. The area of the paper used here will be area of figure 1, area of figure 2, area of figure 3, area of figure 4, area of figure 5. Replace these value and add it. This is the area of this figure or the shape made out of a paper. So you take your own time to do the calculation because we have 5 shapes here: triangle, trapezium, rectangle and right angle triangle. In this we have used the Heron's formula. In this, half base into eyes. In this figure shape second, it is a rectangle, length into breadth, and it is a trapezium which I have drawn it separately to find its height, which is the height of the trapezium also. And the area of this shape is the area of all the area of triangle first, area of triangle fourth, area of triangle fifth, area of the rectangle second, and area of the trapezium. Okay, we'll continue in the next lecture. Thank you.